Hello, everyone. My name is Jon Huhn. I'm a software engineer at Microsoft working on upstream Kubernetes projects. And today I'll be talking about the easiest way to get hands-on with dynamic resource allocation, or DRA, using the dra-example-driver and how that fits into the larger ecosystem. For some quick background on dynamic resource allocation, DRA is all about making the most out of the hardware available in your cluster. Workloads that require specialized hardware and topological constraints, like AI and ML workloads, often have trouble expressing those requirements with existing mechanisms like node selectors. DRA has been a hot topic recently, especially over the last 18 months or so, because it makes expressing those kinds of requirements possible. And that's one reason why DRA is required for Kubernetes distributions to be certified as AI conformant. More concretely, DRA is implemented as a new set of APIs built into Kubernetes to express what generic resources are required for workloads. Resources here are usually physical or virtual devices like GPUs, TPUs, or network devices. This diagram shows the new API types and how they relate to pods and nodes. So we have resource slice objects, which describe what resources are available in a cluster, resource claim objects, which describe what resources a pod requires. And the Kubernetes scheduler matches those resource claims to devices in resource slices to ultimately assign pods to nodes. Overall, this pattern is very similar to persistent volumes and persistent volume claims. Once a pod has been allocated a specialized device like a GPU, that device needs to be plugged into the right container so the workload can utilize it. And that's where the notion of a DRA driver comes in. DRA drivers are third-party components generally created by device vendors responsible for advertising the devices available in a cluster and configuring containers to access the devices allocated by Kubernetes. Existing DRA drivers handle several different kinds of devices from several different vendors. Now, if you're interested in getting a feel for DRA but not sure how to create a cluster with access to specialized hardware or want a cheaper alternative, there's an easy way to get your hands dirty with DRA. And that way to get up and running is the dra-example-driver. It's a simple but complete driver that can turn any Kubernetes cluster, even a kind cluster on your laptop, into a DRA sandbox. Once the driver is installed using the instructions in the README, you can start making requests for mock GPUs using resource claims. The repo also includes a few examples showing how to do things like share devices between pods and containers, and define device configuration for each individual request. And even though the devices managed by the driver are entirely synthetic, I think it's a great tool to learn about how all the pieces fit together. So once you've gotten the basics of DRA down with the dra-example-driver, there are some ways that you can dive deeper. The tutorial in the official Kubernetes docs by Laura Lorenz uses the dra-example-driver to go into more detail about the components that make up DRA drivers in general, and provides more commentary than you'll find in the dra-example-drivers demo. DRA intersects with many parts of the Kubernetes ecosystem, like auto-scaling and batch scheduling. And since the dra-example-driver is a lightweight and portable tool, it's a great tool for testing these integrations. For example, SIG Scalability has a set of tests which use the dra-example-driver to assess the scalability of DRA in 5,000 node Kubernetes clusters. And the Slinky project, which brings the Slurm workload management framework to Kubernetes, is also leveraging the dra-example-driver similarly. If you use or maintain a project that integrates with DRA, the example driver is a great tool to use in tests and experiments. And as the feature set of DRA evolves, we want the dra-example-driver to be able to demonstrate as much of that feature surface area as possible. If there are any new features of DRA that you're particularly interested in, like partitionable devices, consumable capacity, or extended resources backed by DRA, we'd love to provide examples for those. So please share that feedback by opening an issue or even a PR. Hacking on the example driver is a great way to learn about those new DRA features. And that's the DRA driver, example driver in a nutshell. So please try it out and let us know if there's a way we can make that more useful. And if you have any other questions or feedback about DRA or the example driver, the Working Group Device Management Slack channel is a great place to share that. And as always, feel free to tag me on GitHub or Slack if you need any help. Thank you.